Okay, ladies and gentlemen, today we are going to talk about the different properties. Many of these you've seen before, and you've probably studied in 6th grade and 7th grade. We are going to go over these as just a general review, because later on in the year we're going to have to take these properties and actually apply them to different situations. So you won't be just recognizing the properties, you'll be actually applying them to things like solving equations or order of operations. So let's go ahead and get started. We're going to do the first page. There is a back page. We're going to do the first page, and we're going to kind of group some of these together as far as their definitions go, but we will break it out with different types of examples. So our examples will be, we'll do what we call an algebraic example here, which means we're going to be dealing with variables, and we'll do a numerical example here so that you can see the difference in the two. All right, for the first one, we have the commutative property of addition and the commutative property of multiplication. Basically, their definition is the same, it's just one is dealing with addition and one's dealing with multiplication. So to kind of shorten up your notes a little bit, we're just going to add those definitions together and make it a little bit easier for you, okay? So on the first one, with commutative order, it talks about commutative property, it talks about changing the order. So this is your order property. Okay, and same thing here. So what your definition says is that changing the order of the numbers does not change the answer. Okay? So what does that look like algebraically? Well, what that shows me is that I can take any number plus another number and flip them, and I'm going to end up with the same answer. So A plus B equals B plus A. As multiplication, it would be A times B equals B times A. So that's the only difference. That's why I just went ahead and made the definitions for both at the same time. Numerically, 2 plus 3 equals 3 plus 2. Both of these equal 5. Algebraically, 2 times 3 equals 3 times 2. And this says 6 equals 6. All right, so that is your commutative property of addition and the commutative property of multiplication. All right, so for our next two, this is one you've probably seen many times before. This is the associative property. The associative property is also known as your grouping property, because it changes the grouping of the numbers, not the order at all. So if the order changes, that's going to be your commutative property. But if your grouping changes, that's going to be your associative property. I'm going to do the same thing like I did up here. I'm going to use these two boxes for one definition for both, being that the only difference is the addition or multiplication symbols in the actual problem. So this one says changing the grouping of the numbers does not change the answer. Okay, so this is one of those properties that does contain parentheses. Now that's not to say that other ones don't, but this one will always have parentheses. So in other words, if we're talking about the associative property of addition, we're going to say that 2 plus 3 plus 4 is going to equal 2 plus 3 plus 4. And I just put that in the wrong spot. That should have been on that side. All right, so notice that the order didn't change. The symbols, the grouping symbols, your parentheses moved. All right, so these should have switched places here. And I'll do the algebraic one down here. So this is going to be A times B times C equals A times B times C. Again, ABC order, however, the parentheses moved. All right, so then I'll do the algebraic one here. Sorry about that. So this is going to be A plus B plus C equals A plus B plus C. And I'll do the correct one over here. So this is going to be 2 times 3 times 4 equals 2 times 3 times 4. Okay. All right, so those two properties you actually should have seen many times before, but just as a review, okay? All right, so the next one is your distributive property. Your distributive property, again, I'm going to use the same definition because the only difference is sometimes your distributive property will have addition and sometimes it will have subtraction. All right, so my definition here says that with the distributive property, you are going to multiply the number outside the parentheses to each number inside the parentheses. Okay. Now normally there's 2 numbers inside the parentheses, but there can be more. Very unusual for there to be less, but that's not to say that that couldn't happen either. So your distributive property says if you have A times B plus C, you're going to take this and you're going to multiply it to each piece inside. So it would be A times B plus A times C. The only difference would be between this one and this one is the subtraction symbol would be there. So it would be A times B minus C. And you're going to still take this and multiply it to each piece. A times B minus A times C. Okay? And that's going to become really important when we do equations later. So let's do our numerical. So 2 times 3 plus 4. You're going to take this 2 and multiply it to each piece. So 2 times 3 plus 2 times 4. Same thing here, but I'm going to put a subtraction symbol instead. So 2 times 3 minus 4. So 2 times 3 minus 2 times 4. All right, so those properties should look very familiar to you. I know that you've studied them before. We're going to flip this over and add a few more to this. Again, they're probably properties you've seen before, but we're going to review for purposes of later on. All right, so on the back, we have the multiplicative property of 0, or 0 property of multiplication. Doesn't matter how you say it. But this is something that you guys have really known about for a long time. You started doing your multiplication way back in elementary school. So you're going to understand the concept behind it. You just have to be able to associate it with the actual wording of it. So what your property says is that any number times 0 equals 0. And you know this, because if I said, what's 10 times 0, you would tell me 0. If I said, what's 100 times 0, you would tell me 0. So that is not anything that you haven't seen or heard before. We just need to make sure we understand what the property is that goes with it. So if we do our algebraic, A times 0 equals 0. Or we could say 5 times 0 equals 0. Okay? Now additive inverse. And if you think of the word inverse, I want you to think of the word opposites. Okay? And when we think about adding opposites, you should be thinking of positives and negatives, is what that should kind of hopefully bring to mind for you. So when you're talking about your additive inverse, it just says any number plus its opposite equals 0. That's it for that definition. Really simple. And again, not a hard concept to understand. It's just making sure you understand the name of the property that goes with it. So any number plus its opposite equals 0. So if you have $5 and you spend $5, you have no dollars left. That's what that's saying. And we all understand that. Multiplicative inverse or inverse of multiplication. Again, we're thinking opposites. And you're going to hear a word that you've probably heard before, but you may not remember, reciprocal. Okay? A reciprocal is where you have a number and you multiply by its inverse, which means you're flipping it. So if you have a number like 2/3, its reciprocal would be 3/2. So when we talk about reciprocal, that's what we're talking about. Sorry about that. I didn't realize I was that low on the screen. So let's go ahead and get a definition here. Any number times its reciprocal equals 1. Okay, that's your definition. So what does that look like? Algebraically, any number times its reciprocal equals 1. And mathematically, let's say 8 times 1/8 equals 1. Remember, the reciprocal of a whole number puts that whole number in the denominator, and your numerator becomes a 1. Additive identity. When you think of identity, think of what you see when you look in the mirror. You see yourself. Your identity doesn't change. So in this situation, we want to make sure that the value of the number doesn't change. So what can we add to any number to keep it from changing? We can add 0, and that will keep the number from changing its value or losing its value. So your definition just says any number plus 0, excuse me, I'm thinking ahead of myself here, plus 0 equals itself. Okay. And again, we know this. We've seen this many times before. So any number plus 0 equals itself. Any number plus 0 equals itself. So if you have $5 and you don't spend any of it, you still have $5 left. Our last property for today is our multiplicative identity. Same concept of here, if we don't want the identity to change, what can we multiply by? Well, we can multiply by 1. So anytime we multiply a number by 1, it doesn't change. So that's really where your definition's coming in. So any number times 1 equals itself. Okay, so we'll do our 2 examples on that. Our first one, any number times 1 equals itself. And we'll just stick with that 5. 5 times 1 equals 5. Okay. All right, ladies and gentlemen, that is it for our notes for today. What I would suggest is if you struggle with these or you have a hard time remembering them, flashcards are a great way to do that. You can do the names of the property on the front, put the definition and examples on the back, and use that to study from. There's also a really great resource called StudyStack.com. You can go on there and search for flashcards that are already done and use it to study from. They have all kinds of fun little games that you can play with it. You can also use that to create your own flashcards, and you can take that anywhere. You can have it on your phone, your tablet. You don't have to be, tied down to cards if you don't want to. So great resource for flashcards, and not just for my class. You could use it for any class in which you have to memorize vocabulary. If you are taking a foreign language, it's a beautiful resource. Look into it if you don't know about it. It really can be super helpful when you've got to memorize things. So that's it for today. We'll have a little bit of practice that goes along with this. And if you have any questions, please feel free to reach out to me or join me in one of our office hour sessions or live sessions so that you can get some help. Have a great day.